Hello everyone. How does gravity on Mars compare to Earth? Let's explore. Gravity. It's the force that keeps our feet planted on the ground and shapes our everyday lives. But what if gravity wasn't the same everywhere? Mars, the red planet, offers a fascinating case study in how gravity can differ from world to world. Understanding the differences in gravity between Mars and Earth is crucial not only for future space explorers venturing to the Martian surface but also for deepening our understanding of how planets work and how gravity influences the evolution of celestial bodies. Let's start with the basics. Gravity is a fundamental force of nature that arises due to the mass of an object. Every object in the universe, from tiny specks of dust to giant stars, exerts a gravitational pull. The more massive an object, the stronger its gravity. That's why we feel the Earth's gravitational pull strongly, while the gravitational pull of a book or a smartphone is barely noticeable. When comparing the gravity of Mars and Earth, the most significant factor at play is the difference in mass. Mars is considerably smaller than Earth, possessing only about 11% of Earth's mass. This difference in mass translates directly into a weaker gravitational pull. So, what does this mean in practical terms? If you stepped on a scale on Earth and weighed 100 pounds, you would weigh only about 38 pounds on Mars. That's right, you'd instantly become more than 60% lighter just by setting foot on the red planet. This weaker gravity would make for a very different experience compared to life on Earth. Everyday tasks like walking, running, and jumping would feel remarkably different. The decreased gravity on Mars would give you a spring in your step. Walking would feel easier, and you'd likely be able to cover greater distances without tiring as quickly. If you're into sports, you could imagine playing a game of basketball where your slam dunks become the stuff of legend due to your ability to leap higher in the low-gravity environment. However, the low gravity wouldn't be all fun and games. Mars' weaker gravitational pull has profound implications for the health and long-term well-being of future astronauts and colonists. Our bodies have evolved to function optimally in Earth's gravity. Extended periods in low-gravity environments have been shown to cause various physiological changes, including loss of bone density and muscle mass. A weakened cardiovascular system and potential disruptions to the sense of balance are also potential health risks associated with long-term exposure to Martian gravity. To mitigate these health effects, astronauts living on Mars would need to incorporate rigorous exercise regimens into their daily routines. They might also need to utilize specialized equipment designed to simulate the effects of Earth-like gravity or take supplements to promote bone and muscle health. It's an area of active research as scientists and engineers work to develop countermeasures to protect humans undertaking long-duration missions in low-gravity environments. Beyond the effects on the human body, the weaker gravity on Mars influences various other aspects of the Martian environment. One notable consequence is its impact on the Martian atmosphere. Over billions of years, Mars has gradually lost much of its atmosphere to space. The planet's lower gravity makes it more challenging for it to hold onto gases, particularly lighter elements like hydrogen. This loss of atmosphere contributed to Mars' transformation from a potentially warmer, wetter world in its ancient past to the cold, arid planet we see today. The weaker gravity of Mars also affects how objects fall and how projectiles move. If you were to drop a ball on Mars, it would fall towards the surface more slowly than it would on Earth. Similarly, if you threw a baseball on Mars, it would travel farther before being pulled down by gravity. This difference could have implications for designing tools, vehicles, and even sports and games adapted for life on the red planet. Understanding the Martian gravity is critical for planning any future missions to the planet's surface. For instance, engineers designing landing craft for Mars need to take the lower gravity into account. Rovers and landers will require different braking and propulsion systems compared to those used on Earth landing missions. The amount of fuel required to launch a rocket from the surface of Mars back to Earth would also be significantly less due to the weaker gravitational pull. Moreover, studies of Mars' gravity can reveal insights about the planet's interior structure and composition. Scientists can analyze variations in Mars' gravity field to infer the distribution of mass within the planet, helping them understand its internal layers, such as the presence and size of its core. Mapping out the planet's gravity also helps identify regions of higher and lower density, providing clues about the geological history and the potential presence of subsurface water or ice deposits. In addition to the scientific value, understanding Mars' gravity has practical implications for the search for resources essential for future human missions. Analyzing the variations in Mars' gravitational field could aid in identifying suitable locations for water ice mining, which could provide life support and potentially fuel production for Mars explorers. In conclusion, while Mars shares similarities with our home planet, the difference in gravity stands out as a key characteristic that sets it apart. Gravity's weaker influence on Mars has far-reaching implications, from affecting the health of astronauts to shaping the planet's atmosphere and its suitability for long-term habitation. As we continue to explore Mars with robots and, one day, with human explorers, unraveling the complexities of Martian gravity will play a vital role in understanding this enigmatic world and paving the way for a future where humans may one day walk its dusty red surface. Thank you for watching. Please follow for more related videos and see you later. Goodbye.